right, guys, so if I remember correctly, last time we talked about if I have a hypothesis test for a percentage, then there are three main things that kind of get modified in the test. They're still the same 5 steps. All steps mean the same thing they did before. The very first thing that should make sense is if I have a claim about a percentage, then I've got to use the letter P and not the letter mu. Cool? So that's one thing. But it's still, if my claim is the percentage is more than 60%, the whole idea about where it goes stays the same. I just got to use the right letter. Right? Don't put mu when you're talking about percentages. The next thing that changes is, this came up a second ago, what do I check for percentage problems to see if it's normal enough? I hear it, NP and Q. Let me see if you guys really get this. Confidence intervals, I have to use the hatted ones. I love that phrase. I have to use P hat and Q. I have to because I don't know P and Q. What's the first thing in the hypothesis test we do? We assume that that's P. So then I'm going to do NP, NQ. I'm going to do, so if N was 400 in this problem, NP would be 400 times 0.6. And so forth. We assume that the number that comes from there is the real middle. And then I say, let me see if I can contradict that by finding a sample so far away from that. So we go into this knowing what the shit P is. So I'm not going to use P hat here. In confidence intervals, again, I had to, because then I had no freaking clue what P was. That's the whole point of a confidence interval is, I don't know what the shit it is. Let's see what it looks like it is. And maybe. All right. I was always excited about that. So use the right letter. Use the right test. Third step's the same. The great thing about the third step, anybody remember what the third step was? After this. Yes, rejection region. So third step stays the same. And the really beautiful thing about NPQ problems is you only use Z or nothing. T-scores were invented for sample mean situations. In fact, we only have 3 confidence intervals formulas, not 4, because there's only 1 for P. It's got a Z in it. Maybe. So the third step stays the same, but it's really nice because it can't even be T-scored. It has to be Z. And then the fourth step changes because I can't use this dude because I ain't got no freaking means. Right? So then we had to develop what the Z-star formula would be for a percentage problem. We've never seen that shit before. So what we did was, here's the main idea. How far away is my sample percentage from this guy? But then I got to divide by the spread. And we had already figured it out earlier. We had created it from the, let me see if you guys, I'm pretty sure I got this far last time. Yeah. Here's the confidence interval formula. And here's the one for means. What's the spread in this statement? What part of that is the spread? No. That's the error. What part is the spread? That's the spread, right? Yes? Yes? So then what's in the same place in the formula that we created for percentages? So that is the spread for situations where I'm taking samples of and finding percentages. That's the spread. And again, over here, I don't have to use the hats. Because over here, I know what P and Q are.
So is that the spread as well?
Yes, that's the spread. Right here, this is the spread. So that's the spread for P hat problems, for P and Q. Huh? I think it's pretty. I know, I'm weird. It's too bad. All right. So some of you guys look up there and you say, well, the whole damn thing's different. But hopefully some of you guys realize nothing's changed. They're all the same 5 steps. use the right letter, use the right test, use the right z-score formula. Ooh, but the steps don't change. So guess what I got? Yeah, I do. I got a worksheet. So let's do one side of this together, one side you guys alone, and then I'm going to have you guys test each other to see who's got mind reading capabilities. I have to do that so I can weed them out. Start wearing my tinfoil hat. Get out of my brain. You in the government. Cool down a bit. Heat it back up. So leave it there. All right. We definitely didn't do this problem, right? The Chicago policeman problem? Okay. Just gotta keep it straight because I have another stats class. So let's use it. Try not to do it right. What do you guys see? What claim is being made? At most 55%. So how do I write that in math? Yeah. So at most means up to. So less than or equal to 0.55. That is the claim. So what slot does it get thrown into? That whole experience was really bad, sir. And then, what's the other one? P greater than 0.55. I like it. So whenever you're done with the hypotheses you're writing down, just make sure somebody's got an equal sign, it is in the null, and that they are really opposites. 1 or 2 tail test. Where? Up here, greater than 11.
You always base it off of the high.
The high, exactly. Generally don't want to base too much off the high, but in this case you base the rejection region location off of your high. Is it normal enough? What do I got to check? What's n?
996.
Good, 996. So what's n times p? 996 times, shouldn't have to do any work, 0.55. And NQ is going to be 996 times, that's right kids, 0.45, right? If P is 0.55, Q is 0.45. Very cool. I shouldn't have to calculate P hat until the step where I actually worry about the sample. It hasn't gotten there yet.
So P is what you, or like what the person claimed, like the percentage of the
Yeah, so the way hypothesis tests work, again, is H1 says, oh, you think it's around 55%, do you? Okay, assuming you're right. So we assume that 0.55 is correct.
Oh, okay.
Let's see if my sample goes crazy. It's kind of like a proof by contradiction. We want to contradict that it's at most 55%. So assuming it's right, let's see if we can do something freaky. I don't know. You guys, what is that? 540 something?
Yep, 547.
Or 47 point blah, blah, blah. And then this is going to be 448 point blah, blah, blah. That's definitely at least 5. So what's that mean? Yes. Because the question was, is it normal enough? So it means it's normal enough. Normal enough to do what? Walk around in public. No, stop. Normal enough to what? And you're all like, dude, you're the one that came up with that. Why do you have to do that check? Why couldn't I do the next step if I didn't do that check? Because the next step is going to come from where? It's going to come from a chart that assumes I have a normal. So I can't use the charts, either one of them, unless I have a normal. So one thing that Stats 2 does is it lays the groundwork for, okay, what do you do when you don't know it's normal? And then you get some more things if we had a Stats 2. Universities have Stats 2 because they're all that. All right, so I got a one-tailed test. I can use, what does this mean up here? The fact that it's normal enough means that I can use z-scores. If it wasn't normal enough, couldn't do anything. I love it. So the answer for percentage problems is never T. Yes? Oh, if P is 0.55, Q has to be the rest. Yeah, so they have to always add up to 1. Yeah. The hatted ones, whatever clothing, the naked ones, the naked ones, see this guy? It's all naked. Still has to add up to be 1. Anytime. So I know I've got an alpha of 0.005, z-score. I know it's a one-tailed test. And you look at your t-score chart, now that we know we're allowed to, figure out what that is. One tail, 0.005. So what column are we in? First one. Z-score, so I'm just not going to stop. 2.576. And again, don't freak out if you start remembering some of these numbers. And if you don't remember some of these numbers, well then, fine. How do I say this picture, what this picture represents in words? Yep.
Okay, so you say C star is greater than.
Greater than. Kick ass. What can I do?
Reject the
So there's only 2 things that can happen. Either this one thing can happen, and again, this is another situation where students might think I'm insane. That's one thing, right? If it looks like he's wrong, that implies that it looks like the other guy's right. So this is one thing. Either I can do these or I can fail to do these. That's it. And never forget, why does it make sense? The null thinks it's where? The null thinks it's here, right? Equal to or less than, so it thinks it's in here. So if I get a sample that's there, it looks like the null is wrong. I can reject what he's saying. That's it. And if I reject the null, that means what do I do to the high? I must support that guy. Notice I don't use the word prove. I don't use the word accept. Support is what evidence does. Evidence doesn't prove something. Maybe. All right, so now I can summarize what I know from my sample. I know n is 996. I know x is what? What's x? 594 successes. So that'd be 594 out of 996. Whatever the hell it is. 0.59. 6. Okay. Crowdsource that. And now we just throw stuff in. It's all right. Does this z-score formula look the same as the one we used before? No, but it's the same. Our data minus the supposed middle divided by the spread. That doesn't change. That's my claim. And I did the test and I found enough evidence to support that claim. Shut up, Jeff. All right. What goes in here? This is where things get a little bit tricky.
0.55.
Good. P, which is 0.55.
Times
0.45. Yeah, divided by the whole n. Another big mistake I see is people use the wrong number there. It's got to be the bigger one. It's got to be the entire sample. And now you just throw that in the old calculator, hopefully correctly. This is another place where things can go wrong. There's a lot of shit going on here. Don't see that. Ooh, there you go. So that's how to do it correctly. Tell it what the top is. Make sure you don't come out of the square root too soon. And I get, what do you guys get? Anybody?
2.9.
Yeah, I get 2.92. You guys all right out there? Yes. What'd you get? You all right? Just, okay.
I'm scratching
Anybody else? Morgan, you all right? Did you put that formula in? Did it come out right? No. You all right? What's up?
All right.
You all right?
Yep.
Did I stop? Point me out. Anytime we do this and your calculator doesn't come out the same thing, please just call me over. You're going to have to be able to do this on your own, so 2.92. Did we make it far enough away?
Yes.
Hell yeah. Way the shit out there. So right there, before I do this p-value, I already know the answer. What can we do since we made it in there? What can I say right here? I kind of hear it out there. You guys, it's almost like being in Children of the Corn. You can hear whispers out there. Yes. We did what we said we had to do to be able to do this, therefore we can do this shit. Yes?
I still can't, like, I'm not getting the right answer in the calculator. And I'm putting it, I think I'm putting it in correctly.
Oh, very beginning. You got to put the top in parentheses, or else it's just going to divide 0.55. You want to divide that whole thing.
Yeah.
Yeah. Whoa. Divided by, that's what you want. Ask what your value is. Just don't put it in parentheses, just put it in 5 times. Divided by that thing of the jig. Everybody else all right? Okay, better late than never to tell me. Can somebody find the p-value for me? What's the value, brother? It's only a one-tailed test, so you don't have to worry about doubling anything. 0.9. Beautiful, because this is what it is, not in the tail. So then 1 minus that, 0.0018. Is that a good p-value? Why? Wrong way around. It is small. The smaller the p-value, the more likely it is that your conclusion is right. Now there's a lot more to this story involving, well, there's something I haven't talked about yet that I don't know if anybody's run across in the homework yet, type 1, type 2 errors.
Yeah.
Alright, so I'm going to talk about that like right after you finish this conclusion. What is my conclusion? Well, what's my claim? Which one? Yes.
Do we double the p-value?
Only if this was a how many tail? If only if it was two tail, because then you're kind of making it fair to compare to alpha.
So
Yeah.
you wouldn't double.
I don't need to double if it's just one tail. Yeah. Which one was my claim? Yeah, not the high, because you can see there's my claim right there, right? There it is, right? And where did I put it? Yeah, so the hoe is my claim. So how am I going to word my conclusion?
Sufficient evidence to
Reject the claim that blah blah blah. That's yeah. We have found sufficient evidence to reject the claim that at most 55% of Chicagoans, is that how you say it? It's not Chicagoites, that'd be a little weird, yes. Oh, let me finish this out and then we'll come back. That at most 55% of Chicagoans have an unfavorable view. What a nice way to say an unfavorable view of the Popo. Sorry. Not Mr. Popo. Sorry. So the p-value is just the area in the tail that this makes. So there it is right there, right? So when I find the area in this tail that 2.92 makes. So if I look it up on the chart, I get that area. I got to do 1 minus to get the other side. Yeah.
How did you know it was a 1 or a 2 tail test again?
Because only one direction will show evidence for that. It's got to be above. If it was not, the only way it could be a 2-tail test is if H1 says not equal to. No. If H1 says not equal to, how could I show something's not equal to something else? Bigger or smaller. That's why it's 2-tail. So the tail is where evidence would be found. If I get less than 0.55, is that evidence that it's greater than 0.55? No, right? It's almost too silly of a question to take serious, right? You're all like, you just said weird shit. Yes, I did, because that wouldn't make any sense. That's why it's a 1-tail test. It's only one tail in which evidence could be found.
So it's in the H1 then?
Yes, H1 always sets up my rejection region. Yes?
Could you repeat one more time? Why you want a smaller p-value?
Yes. Another way to test a claim. Now, we knew the minute I got 2.92, it was bigger than this, so I knew right there. Guys, the p-value is the size of my tail, right? My Z-star's tail. And alpha is the size of the rejection region tail. If I pass a hypothesis test, I'm further away, my p-value should be less than alpha. That's another way to test a claim. My p-value was 0.0018. It's off the picture, which is smaller than, where'd the alpha go? 0.005, right? 0.0018 is smaller than 0.0050.
But it'll only be, say like,
So,
say the rejection region was on the opposite side, this would still work, like say the p-value should still be less than alpha if it passes that.
if your rejection region's on the wrong side, you wouldn't even do the test. If my claim was it's less than 55%, and my sample's got 59.6%, I'm not doing the test. I'm not. There's no point. There's no way that could be evidence that it's less. And technically, the tail has to be the same direction as the rejection region. So you would have a big ass tail.
What do you mean like a tail that was going this way? Like the same thing but on the opposite side?
Oh, everything's on the other side.
Yeah.
Then the p-value would have been the same.
Okay.
And when I look up negative 2.92, which is it would have then I would have gotten 0.0018 directly, because then it would have matched up with what the chart tells me. I like it. Now, I think your question was, what's a p-value mean?
Kind of, yeah.
Okay. P-value is the probability that I would get a sample where I did if the mean was in the right place, or in this case, the percentage is in the right place, the population percentage. Let me say that again. The p-value is the probability that the null hypothesis is true, is another way to look at it, given that I found that sample. So is it very likely that the null is true? Let's try this again. Is it very likely that the null is true, considering this is the probability? 0.0018, so you should be saying no. That's not likely. No.
No is like the null, right?
Yes, yes. The appropriate name is null, and then the Jeff name is ho. Yes. And again, if you're offended by that, then I don't apologize. I don't. Get over it. Okay. If you want to complain, do it. I love it. That would be awesome. Talk to my dean about O's and I's. What else I want to say about that? Yeah. That's why in a journal article only reports a p-value, because it lets everybody have their own alpha. Everybody can have their own level of evidence they need. And a p-value 0.0018 should pretty much pass almost anybody's test. You kind of with me? That should be really good evidence. Let me talk about this right now, since this kind of ties into that. If you have been doing the homework, you should have hit questions about types of error. So tell me, there's only two things you could do with a rejection, with a hypothesis test. You can either end up rejecting the null, which means support the I, or you can fail to reject the null. Right? Which means fail to support the I. You guys with me? There's only two things. Because either you get in it or you don't get in it. So there must be only two things that happen, because there's only two things that could visually happen. The funny thing is it impossible? So we found evidence to reject the claim. Does that mean the claim is definitely wrong? We found evidence to reject the claim. Does that mean the claim is definitely wrong? No, in fact, we didn't use the word proof, did we? We didn't prove shit. Yay, go us. There's a very small chance that that conclusion is wrong, so therefore we live with it. That's the within a reasonable doubt. We have to live with that, because that's life. We're never going to know 100% for almost anything. So we have to work with these, what's expected, what's not expected. That's unusual, so therefore that seems to be evidence, right? If I flip a coin 100 times and get 99 heads, I'm going to question my own life and then question that coin, right? Is it impossible to get 99 heads if you flip it 100 times? Is that impossible? Some people think it is. Even some of the ones that said no right now actually think it's impossible. It is not impossible. It is just really, really unlikely. But that would be really good evidence that something weird happened with a coin. How would I verify it? If I flipped a coin 100 times, got 99 heads, I'm like, oh shit. How could I verify that? Or how could I find further evidence for it? You could do it. Come on. I could do it again, right? Couldn't I flip it 100 times again? Or even better, I could get somebody else who is as bored as I am. Flip that coin 100 times. That's even better. This is why, how does science work, kids? One group finds something. They say, oh shit. Hey, can you guys try this and tell us what you see? They do it like, we saw the same thing you did. Holy shit, let's write that in a journal. Yeah. I mean, you normally don't report something if you've only got one experiment that you've done that shows evidence. You want to verify that. You want to have independent verification. You want somebody else to do it. In case somebody on your team is biased or some equipment you got is not calibrated right, whatever.
What did bias mean?
Huh?
What did bias B-I-A-S, is it?
Oh, biased. Yeah, we know what biased means. It was back in chapter 1. It's about, like a sample could be biased if you choose only your friends, because they're going to have certain feelings that kind of match up with your own, right? So that your results would be thrown off. Yeah, I like it. So I could have somebody in my group who's kind of like unconsciously only taking the results that kind of match, right? Or consciously, to be honest. You never know. All right. Okay, coming back to this. So, we never know what the real truth is, right? And this is like a philosophical moment here. Do we ever know? No, we don't. We don't have a flipping clue. So what kind of mistake, even if we do everything right, you're not going to lose any points, but what errors could you have made? If I reject the null, when would that be false? When would that be a bad thing to do? If the null was actually, if I reject the null, when would I be wrong? If the null was actually true. So if I find evidence that somebody's guilty, so I reject the null that they're innocent, is that always come out, is that the right thing always? No. There are people on death row that shouldn't be. Right? Yes, no, and we won't get into all that. I'll leave you out. Okay. So type 1 error. The type 1 error is reject a true null. That does not mean you made a mistake in your work. If I come across a population of these new creatures and I take a sample of them and I make a claim about from my sample, of course I could be wrong. I don't know shit about these creatures. But I'm going to work off of what's more likely, right? Because that's all I got. I just got a sample. A type 2 error. So when could the other one be wrong? If I fail to reject the null, I don't care about it. You just said the same thing I did, right? If I fail to reject the null, when is that a bad thing to do? If the null was actually, I failed to say he's wrong. That's bad if he's actually wrong. So if I fail to reject a false null, that's type 2 error. Fail to reject a false null. Okay. Yes. Reject a true null. Yeah.